In the previous video, we learned about cognitive load, different sources of cognitive load, and how too much cognitive load can max out our students' limited working memory space, making it difficult for them to learn. Next, I want to show you just a handful of examples of how instructional methods can unnecessarily add to cognitive load and what we can do about them. Now, imagine I give you this figure because I want you to learn to identify the 4 lobes of the brain. Where is the occipital lobe? How many steps do you need to go through in order to figure out which lobe is the occipital lobe? At least 3, right? Each step adds to the total cognitive load of this task. How about this figure? Where is the parietal lobe? Did this feel a little easier? That is probably because I have removed some of the steps you need to take in order to answer the question. Processing the information in this figure carries a much lighter cognitive load than the previous figure. What that means is that you have more capacity in working memory to do other tasks, such as to consider where the parietal lobe is in relation to the temporal lobe, and how the size of the occipital lobe compares to that of the frontal lobe. These simple tasks would have been much more difficult using the previous figure. So, one question to always ask yourself when presenting information to your students, whether it be an image, text, or other format, is how can I simplify the information? You can find many different ways to simplify information, but one that I used here was to reduce the number of steps needed to process the information. Or think about the number of steps needed to complete a task that students need to perform. Another way I reduced cognitive load in this example was to place related information close together in space. In this example here, we can see that the number of steps to take are the same, but when the labels are further away in space from the lobes they represent, your mind has to work harder to process the information. So whenever you can, place related information as close together as possible because it reduces cognitive load and leaves working memory capacity available to do more complex tasks with the information. In this video, I'm going to present 4 things that you can do as an instructor to help reduce unnecessary cognitive load. So far, we have talked about 2 of them: reducing the number of steps, and placing related information close together. With these same tips in mind, I'd also like to show just one more example of how you might apply these principles to how you design your online course. I saw a course once where the instructor separated the list of lectures from the list of assignments. Further, there was no sort of schedule tying everything together. On one page, there was a list of lectures that looked similar to this. No dates or weeks to which each lecture was to be associated, no organizing structure other than that the lectures were listed in a numerical order. Then, students needed to navigate to the automatically generated course summary at the end of the syllabus to look and see when each assignment was due. There was no clear way to identify which lectures went with which assignments. This setup would have added too much unnecessary cognitive load to what students were in the course trying to learn in the first place. Can you guess why this setup increases cognitive load? Like we saw earlier with the figure of the brain and its labels, the more steps students need to take in order to find the information they need, the greater the cognitive load of the task. Further, the more spread apart related information is, the greater the cognitive load. So do your students a favor and make sure you place all of the information students need for a given week or a given lesson in one place. You can accomplish this with a weekly guide that lists everything students need for a given week or lesson. You can accomplish this using modules where all of the components are nestled within their respective modules. Or you can even accomplish this with the course schedule. In this case, students still need to take additional steps to access each component, so there is some added cognitive load in this approach, but at least they can see everything they need to do for a given week in one place. Okay, we've talked about reducing the number of steps to complete a task and placing related information close together. The third tip I want to talk about is simply to avoid clutter and unnecessary information. So long chunks of text like this can really carry a heavy cognitive load, especially when they contain new information that students are learning or involve instructions for students to follow. These were the instructions for one of my early assignments, which even just glancing at is quite overwhelming. Never mind the fact that merely completing the assignment alone involved a heavy cognitive load. Here is part of that same assignment for a more recent semester. You can see that I've started using headers, which helps to create a sense of organization. I've broken up the long narrative format into digestible chunks, and I use bullets and lists where I can, which helps to reduce the number of unnecessary words. So I'm at least on my way to a clearer set of assignment instructions that doesn't add too much to the existing cognitive load of the assignment. Related to how we present text, I want to show you one last example that illustrates the fourth and final tip I wanted to share for reducing unnecessary cognitive load. To illustrate this last example, I'm going to pretend I am lecturing on the topic of surface strategic and deep learning. I'm going to demo two different approaches that differ on what visual information I present. Okay, here's the first approach. When thinking about surface strategic and deep learning, imagining a deep sea diver exploring an iceberg can help. You can think of what is to be learned in a class as the iceberg. Surface learners never really dive deep enough to see the part of the iceberg that is below the surface of the water. And so they can't really see, like deep learners, how what they have learned comes together or what it is that supports that knowledge. Strategic learners also skim the surface, so they never really see the whole iceberg either, nor do they have a very solid foundation for what they have learned. But they use what they can see from the surface to selectively dive down to certain deeper parts of the iceberg, hoping to learn more deeply only in areas they suspect will give them the best grade in a course. Okay, let's try this again, but with a different slide for you to look at while I talk. When thinking about surface strategic and deep learning, imagining a deep sea diver exploring an iceberg can help. You can think of what is to be learned in a class as the iceberg. Surface learners never really dive deep enough to see the part of the iceberg that is below the surface of the water. And so they can't really see, like deep learners, how what they have learned comes together or what it is that supports that knowledge. Strategic learners also skim the surface, so they never really see the whole iceberg either, nor do they have a very solid foundation for what they have learned. But they use what they can see from the surface to selectively dive down to certain deeper parts of the iceberg, hoping to learn more deeply only in areas they suspect will give them the best grade in a course. Okay. So, which example felt the easiest to process? The one with the text or the one with the image? Likely, your experience was that it was difficult to pay as close attention to the message in the first example because of something referred to as the split attention effect. It is believed that working memory primarily deals with two modalities or channels of information: auditory and visual. Too much of one type of information overtaxes working memory, holds a heavier cognitive load than mixing up the types of information. Although text is processed visually, it interferes with the auditory channel because it has to be translated into an auditory signal. In the first example, your attention was split between listening to the words I was saying and reading the words on the slide. In the second example, you were processing both what you were hearing and what you were seeing, but the example held a lighter cognitive load because what you were seeing was presented in a different modality than what you were hearing. So our fourth tip is to avoid the split attention effect with too much text, because it is usually text that gets us into trouble. Too much text doesn't just interfere with what we are hearing, it can also interfere with other visual information. Here, in this example, we get the split attention effect because we have too much visual information to process. Our attention is essentially split between looking at and processing the image while also trying to read the text to the right. While adding images to lesson materials is typically helpful for learning, they can interfere when the expectation is to process both at the same time, as in this slide. A learner is expected to jump back and forth between each bullet point and the image. Okay, we talked about 4 tips for reducing cognitive load in the way we present information to students. Can you remember all 4 tips?